In this video, I want to define join problems and look at strategies we use to solve these. Join problems involve some kind of action, whether direct or implied, in which one set is increased by a particular amount. In these problems, we tend to have a starting quantity, a second quantity that's joined to the initial, and then the result, the final quantity. And depending on which one of these is missing, we can form different types of join problems. So let's look at the three different types and how we go about solving them. The first type is a result unknown. Andy had 6 toy cars. A friend gave him 8 more toy cars. How many does he have now? So here we had our initial set, a second quantity that we added to it, and then the result, which is what is missing. If we use direct modeling to solve this, the most common strategy would be joining all, having a set of 6, a set of 8, and then counting them together. The most common type of counting strategy would be counting on. We start at 6 and then we count 8 more to get to the final answer. And in these result unknown problems, we can do a basic number sentence that we are looking for something like 6 plus 8 equals what? So this is the basic form of number sentence for the result unknown join problems. The next type of join problem would be change unknown. This time we know our initial amount and we know our final amount, but we don't know how much it was changed by. As an example, Andy had 6 toy cars. A friend gave him some more toy cars. Now he has 14 toy cars. How many did his friend give him? So we have our initial amount, an amount we're changing it by that we don't know in this case, and then the total together amount. So this would be a join problem where the change is not known. The most common type of direct modeling strategy we use to solve this would be joining 2, starting with a pile of 6, counting until we get to 14, and then determining how many that we had to add in. And the most common type of counting strategy would be counting on 2, starting with 6, counting up to 14, and then realizing that we had to count 8 extra numbers. If I want to look at the basic form for a change unknown problem, it's going to be something like 6 plus what equals 14. So this is the basic form of the number sentence for change unknown join problems. The last type of join problem would be a start unknown problem. As an example, Andy had some toy cars. His friend gave him 8 more toy cars. Now he has 14 toy cars. How many did he have originally? So our start value is unknown. We have another value, a second set, and then we want to combine them all to get 14. So this would be a join problem with our start unknown. With start unknown join problems, direct modeling and counting methods will both have the most common strategy of trial and error. And if I want to look at the basic number sentence here, I would have something plus 8 equals 14. So this is the basic form for our number sentence for start unknown join problems.